For problem 6, our goal is to determine the probability that the average score of 20 people would be less than 95. So we want to determine the probability that x bar, our sample mean, will be less than 95. Well, we already saw in the previous problem that x bar is normally distributed with a mean value of 100 and a standard deviation of 3.35. If we want to find the probability that x bar is less than 95, we can go through and calculate our z-score to find this. So we will get z is equal to x bar minus mu divided by sigma over the square root of n. Now remember that mu is the same thing as the first number in our sampling distribution, so we can plug in 100 for mu. And sigma over the square root of n we've already calculated as well. That's 3.35. We can plug that into our equation as well. So z will be equal to 95 minus 100 over 3.35. This gives us a standard score of negative 1.49. Remember, you are allowed to get negative numbers for your z-score, and in this case we should get a negative number because our original value of 95 was below the mean. Now we need to go back and plug negative 1.49 into our z's table applet to figure out the probability that the x bar should be less than 95. Coming over to our z-table applet, again, since this is a z-score, we have a mean of 0 and a standard deviation of 1. We want to figure out the probability of being below negative 1.49. This gives us a probability of 0.0681. So again, the probability that z is less than negative 1.49, we went over to the applet and we found that this is equal to 0.0681. So it's not very likely, but it is possible that we could take a sample of size 20 and get a sample average IQ that is less than 95.